Well, good afternoon. It is 3/8 dividing decimals by whole numbers today. So now we're changing gears a bit from our multiplication to dividing. What I want you to do is go ahead and hit pause and copy down this information into your notes. So go ahead and do that. Well, for the first one, it says step 1, put the decimal point directly above the decimal in the number being divided, which is the dividend. Okay, so when we speak of that, we're talking about this down here. Okay, the first number given. Okay, and then here's another note. First number is always the number inside the division sign. Okay, that's inside the box of the division. Okay, it's the first number you always read when you divide it. It's the first number you read when you work left to right as well. And we're dividing it by 2. So the first thing you need to do is move that decimal up before you even put these numbers in, okay? Because the decimal is not going to move. It's going to stay right there in this situation, okay? Then you simply divide as you would with a whole number. Now it's just as though it were 68 divided by 2. And the 2, since 2 goes into 6 3 times, you put the 3 above the number, the last digit that you're working with, which is 6. So we subtract 6 from it, and you got 0. Then you bring down this 8, okay, the next number, and then 2 goes into 8, as you can see, 4 times. And again, since we're dealing with the 8, that's why the 4 goes over the 8. And then we subtract 8 because 2 times 4 is 8, leaving us with nothing left over, okay? So again, a recap. All you're doing, this is the example they give you. Okay, the first number given, that's what goes in our division box. Then the second number is what's on the outside. We move this number, the decimal point straight up to the above it, and then we simply solve it as though the decimal did not even exist. Okay, kind of like what we did with multiplication. We tried to pretend that the decimal never was there because we didn't need it until the very end to put in our answer. Okay. So let's try a few problems. I want you to go ahead and do this. I am going to set it up for you first so that you get off to the right track. And again, it is 7 and 49/100ths divided by 14. So go ahead and solve that. So go ahead and hit pause. So the first thing you need to do, again, is move our decimal point up and put it right here. And now we have to ask ourselves the question, does 14 go into the first number, 7? And it does not. This number has to be larger than the number we're dividing by. So 0 times. So now we're going to look at the next two numbers. It is not 7.4. Okay, we're pretending as though this were 749. We don't need the decimal any longer. So 74. So the question is, how many 14s are in 74? And you might have to go off to the side and do some estimating as to how much you think that would be. And we will go ahead and we can say, let's try 3. Okay, and so we get 12 and then 4, and that's 42. Well, that's not seeming to be large enough, so let's try the number 4. And we multiply, and we get 16, and then 5, 56. That doesn't seem large enough, so let's try 5. So then we get 20, and then 7, so we get 70. Okay, and if we were to go another 14, then that's going to be obviously much larger than 74 because we're only 4 away. So 5 is going to be my number for that. And again, since we're working with 74, then that number goes right above that last digit we're working with, which is a 4. So put the 5 above it, and we get 70. And we're going to subtract that from 74, which gives me 4. And then we're going to bring down the 9, the next number. So just bring it down. And now 14 times what gives me a number that's 49 or a little bit less. And if we look back to what we have over here, we can see that we had 42 and then 56 was the next multiple of that. So we'll try 3, which is 42. And we subtract and we get 7. Now, we have no more numbers to bring down. So what do we need to do? We need to add a 0. Bring it down now. Okay, we can add as many zeros as we need to make this number complete. So now 14 times what gives me a number close to 70, and if we look back here, yes, we do have one that is exactly 70, so it will be a 5. Then we subtract 70 from that number, and it gives us 0 left over. Therefore, we are finished. So my answer to this is 535 thousandths. Again, if you're having questions, please make note of that, and we can discuss it tomorrow. Now I want you to go ahead and solve this. So go ahead and hit pause. So now we have 51 and 79 hundredths. That's the number that's inside the divisor. And then divided by 3. First thing we do, move our decimal point up. Now 3 times the first number, and does 3 go into 5 equally or go into it at all? And yes, it does, and would only go into it once. So we write a 1 right above the 5, and 1 times 3 is 3, so we subtract that and get 2. Bring down our next number, 21. How many 3's go into 21? 7, which is exactly 21. Subtract, we have 0 left over. Well, we're not done. Just because we get 0, we still have numbers to bring down. So bring down my 7. So how many 3's go into 7? That would be 2, and again we're writing that 2 above the number that we're working with, which is 6. Subtract and we get 1. Now we have to bring down the next number, bring it down, which is a 9. So how many 3's go into 19? That would be 6, which is 18. We subtract and we get 1. Now we've still got some remaining, so we need to add our 0, bring it down, and we find that 3 goes into 10 3 times. Subtract, we get 9. Subtract, whoops, already did our subtraction sign. And we get 1, and then we can add another 0, bring it down, and we have to go into it 3 again. And you're seeing the pattern. What's going to continue to happen? We continue to get 1. So what number is going to continue to repeat through this problem? Well, as you can see, the 3 will continue to go on and on and on. So what we're going to do at this point is you're going to have to look at the directions. And I'm going to hit pause and make sure that I have the directions correct from the homework. Well, the homework does say that you're going to round to the nearest tenths. Okay? That's what you're rounding to. So where is my tenths? Well, the tenths are going to be this number right here. So we're going to underline that number, okay? And you're going to simply round it to that digit. So my answer is going to be 17, and since we look at the number to the right again, which is a 6, so it's going to make this number go up 1. So it's going to be 17 and 3 tenths, okay? So since the directions do say to round to the nearest tenths, you ultimately would not have to go any further than the hundredths, because any of those numbers beyond that would not matter to determining what happens to the tenths. Okay, so you can put these in here and continue on, or you can go to the hundredths, and we'll talk about that more tomorrow as well and on these next few problems. So really, since it's rounding to the tenths again, you'd only have to go to the hundredths place value and not have to add on zeros. Okay? So let's look at our next problem. Go ahead and solve this. So we have 3 and 49 hundredths divided by 4. First thing again, we move our decimal point up. How many 4's go into 3? Well, it's not large enough. There are 0 4's that go into 3. How many 4's go into 34? Well, there would be 8, which would give us 32. And we can subtract and get 2. Bring down the next number, which is a 9. How many 4's go into 29? That would be 7, which gives us 28. Subtract and we get 1. And now this is where we can do one of two things. Because it is rounding to the nearest tenths, we would not have to go any further. Okay? We wouldn't have to go further because we're only rounding to the tenths. All we have to do is look at one number to the right of that, which in this case is a 5 or more, add one more. So we're going to end up with 9/10 for an answer. Now, if you wanted to, you could move on and add a 0, bring it down, but you can see that we're going to end up going on and on and on, possibly. Now, in this case, we add another 0, bring it down. It does go into it exactly 5 times, which gives me 20. Okay, but that's some extra work that you wouldn't have to do. Okay, all of this that is in blue, you wouldn't have to do. Okay, you can go up to the very end, bring the last digit down, and then as long as it goes beyond the tenths, goes to the hundredths place value, then you would be safe to be able to round it. Does that make sense? If it doesn't, we can again talk about it further tomorrow. So 9/10 is your answer to letter C. Now I want you to do letter D. Go ahead and solve this. And it simply says a bag of 12 bagels costs $7.50. To the nearest cent, find the cost of each bagel. And again, when we talk about nearest cent, we are talking about the hundredths place value. Think of money, $2. Actually, we'll use the number they have, $7.50. Okay, we talk about this. This is the cents. Okay, those are my pennies. That's why we round it to the hundredths place value. Okay, so we've got a bag of 12 bagels that the total cost is $7.50. We've got to find out the cost for each bagel. So we got to take the $7.50 and divide it into 12 equal groups. That's why you're dividing by 12. So we're going to move our decimal point up. 12 does not go into 7, 0 times. So how many 12s go into 75? Well, again, we might have to go off to the side and multiply this out a little bit. We will try 7, and we get 14, and then 84. So that's too many. So now let's go down 1, and we'll try 6, and we get 12, and then 7, so 72. So we're going to write the 6 above the 5. This becomes 72. Subtract, and we get 3. Bring down the next digit, which is a 30, which makes it 30. And then how many 12s in 30? Well, there would be 2, which gives me 24. Subtract, and I get, if I need to do this, I can, and borrow and do all of our subtraction rules that we have to apply. And we get 6. But it does say nearest cent, which is the hundredths. Well, if we recall, we have to go one beyond what we're rounding. We've got to get to this point. This number right here is what we've got to figure out to determine what happens to my 2. So we're going to have to, in this case, add a 0 and bring it down. And how many 12s go into 60? Well, we found, I guess we didn't do it over here, but I know that 5 goes into that. So we get 10 and then 6 for 60. So 12 goes into 60 5 times, and then we get 0 left over. Okay, so now we're able to round this number, the 2, to the cent, which is the hundredths, and it would end up being, since this is 5 or more, we add 1 more to the number we're rounding, and we get 63 cents. And again, we are dealing with money. Please get your dollar sign on there, and that is complete. So if you have questions, again, please write those items down, and we'll discuss them further in class tomorrow. Division, it always takes a little more time. It's always a little more difficult for students. So again, the key to this is ask questions. If you have questions during class, ask then. If you're doing it during charger time, please make sure you come ask. We can always, I know myself and Mrs. Silvius are happy to check a few answers once you get started to make certain that you're on the right track. So please take advantage of that. And many students are, thankfully, and they're learning a great deal from it. Have a great evening, and we will see you tomorrow.